All real-life signals are analog in nature, and at first sight it seems use of analog signal is much better as compared to digital signal. Because if we want digital signal, we need to convert the analog signal by using analog to digital converters. So there is cost involved, we are investing money, and thus we want something better. So in this presentation, we will discuss the advantage of digital signal over analog signal. Digital signal is used in communication process to minimize the effect of noise. So basically we are going to focus how the noise is minimized by using the digital signal. What is noise? Noise is an unwanted signal that we don't want. Let me write this down. Noise is unwanted signal. We have transmitter which is used to transmit the signal, and we have receiver at the other end which is used to receive the signal. In order to transmit the signal, we definitely require some channel, some medium, and in this case we have wired medium. First we will try to understand analog signal, transmission of analog signal, and the permissible range is 0 to 5 volts, and let's say we want to transmit 2.5 volts. So let's see what we have. 0 volt, and this is 5 volts. At any time t1 we are sending 2.5 volts, and in this channel a noise of 0.2 volt is added to this 2.5 volts. So at the receiver's end we will obtain the distorted signal 0, 5. We don't have 2.5 volts at this end because noise of 0.2 volt is added, so we will have 2.7 volts, and this 2.7 volt is considered to be correct because we are sending the analog signal, and in case of analog signal the voltage can take any value within the given limit. It can take any value from 0 volt to 5 volt, and 2.7 is definitely within this limit. So at the receiver's end we will consider the transmitted voltage equal to 2.7, but it is 2.5. So there is effect of noise in case of analog signal. We will consider the same scenario in case of digital signal, and let's see what we have. And we already know there are levels in digital signal, and I want 4 levels from 0 to 5. So 5 I will divide by 4 and I will have 1.25. So let's see what we have on the transmitter's end. 0, then we will have 1.25, 2.5, 3.75, and then 5. And we are transmitting 2.5 at any time, and again a noise of 0.2 volt is added in this channel. And on the receiver side, let's see what we have. Okay, now on receiver side we will have 2.5 plus 0.2 equals to 2.7 volts, but you can clearly see we don't have the level equal to 2.7 volts. We have 2.5, and whenever there is a signal which is not equal to the level, we always take the level below it. 2.7, then we have 2.5. So we will consider the transmitted signal equal to 2.5, and that's what we transmitted. From the transmitter's end we transmitted 2.5, and at the receiver's end again we are getting 2.5. So the effect of noise 0.2 volts is cancelled out in case of digital signal. Let's say this noise is more and it is equal to 1.3 volts. So we will have 2.5 plus 1.3 and it is equal to 3.8 volts. Now we will have 3.75 as the obtained signal on the receiver's end, but the transmitted signal was 2.5. Finally, we can say that digital signal is good for noise rejection when the value of noise is smaller, but when value of noise is high, we have to look for more advanced methods. So this is all for this presentation. We have few more advantages of digital signals over the analog. We will discuss these advantages in the next presentation. So see you in the next one.